Okay, let's begin. We're going to name alcohols. We've already named alkanes and alkenes, so we've gotten familiar with some of the strategies for naming compounds. Now let's apply those to alcohols. The only real difference will be in the ending of the name. Alcohols don't end in ane or ene, they end in ol, O-L. So let's have a look at this first example. The very first thing we will do is determine the longest continuous chain that includes the OH group. That's the parent chain. Next, what we will do is number the parent chain closest to the end closest to the alcohol group. That would look like this. There's a methyl group right here, but OH is more exciting, it's more important, it's more complicated. This is the action. This is what determines where to number. And then we identify if anything is branching off. Sure enough, right there, methyl group on carbon 5. So we have a longest chain of 6. Alcohol group itself is on carbon 3, methyl group on carbon 5. That will look like this. 5-methyl, 3-hexanol. And before we move on, let's make sure that this name makes sense. Hex tells us that there are 6 carbons in the longest chain, 6 carbons in the parent chain. OL tells us that the functional group is alcohol. This is the alcohol functional group. 3 tells us where is that OH. If it had been here, we would have said 2-hexanol. If it had been here, we would have said 1-hexanol. But the OH is on carbon 3, so 3-hexanol. Then we ask if anything else is attached, and it is. We have a methyl group on carbon 5, so 5-methyl, 3-hexanol. This would not be named as a 2-methyl, 4-hexanol. The OH is what determines the numbering. We number closest to the alcohol functional group. Let's look at the next one. We highlight the longest continuous chain that includes the alcohol. We notice there are 2 groups attached. So then we'll number closest to the alcohol functional group, that end. So we'll number from the right. Carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. This is a pentanol. Pentanol because there are 5 carbons in the longest chain. Right away, when I see OL, I need to ask myself, where is the functional group? It's on carbon 1. So that would be a 1-pentanol. If these methyls were not attached, this would be 1-pentanol. But we do have 2 methyls, so we'll say 2,2-dimethyl, 1-pentanol. The di tells me that I have 2 separate methyl groups. If I have 2 separate methyl groups, they each need their own number, their own address. The number for this one is carbon 2. This methyl is also on carbon 2. They're both on carbon 2, so I put 2,2-dimethyl. If this were a tri, I need 3 numbers here. Last example, again, highlight the parent chain that includes the alcohol. Identify what else is attached. Number from the end closest to the alcohol group. That will be from the right end. I can see that this is a hexanol. Alcohol group is on carbon 3, so it's a 3-hexanol. OL for alcohol. Hex tells me there are 6 carbons in the longest chain. The 3 tells me where is the OH group. And then again, we have 2 methyl groups. One of them is on carbon 2, the other is on carbon 3. I would write that like this, 2,3-dimethyl, 3-hexanol. The di tells me I have 2 methyl groups. Each of them gets a number, carbon 2 and carbon 3. So the strategy is very similar to how we've been doing it for alkanes and alkenes. Use these examples to get you started, and then go do lots of extra practice problems on your own.